So in this question, we're going to do partial fraction decomposition of this complicated looking fraction. We've got, in the denominator, we've got x squared here, and this one would FOIL out and make an x squared here. So we've got degree 4 in our denominator, and in our numerator, we've got these terms, and these would FOIL out to make an x cubed. So degree 3 in the numerator, degree 4 in the denominator. So we'll be fine to do partial fraction decomposition with this. Now, these two terms here, what we can do is we can break them apart, and x squared plus 1 will become one of our partial fractions. So our first building block will have x squared plus 1. Now this is quadratic, so we need a linear term in the numerator. So I'll set that up with ax plus b as the building blocks for that one. This one here, I've got x plus 1, and it's the whole term squared. So here we need to build up the powers. So our building blocks for this, we'll have a new variable, and we'll have c over x plus 1 to the power of 1, which is just x plus 1. And then we'll need an x plus 1 squared, but that will also just have a constant in the numerator. So that's our building blocks for this one. Okay, right. Let's just make sure that keeps separate to that. Okay, so next stage, what we need to do is we need to FOIL out all of this left-hand side term here and leave this one like that for the moment. So you'll see what happens with this after we've done that. So we'll have 6 minus 4x, that's already taken care of. And now we need to FOIL out this. So x squared times x, that's x cubed. Now we've got a minus term here, so we do minus and then put everything inside a bracket. So we'll have x cubed, and that times that 1 will give us plus x, and then distribute the 1 with both sides, so we'll have plus x squared plus 1. So that takes care of our numerator, and then same again in our denominator, we just repeat what we already have. Okay, we'll come to this bit in a moment. So we can simplify this off. So we've got minus everybody in here, and we've got a 6 and a minus 4x here. So let's get rid of that bracket and just write this as one term. So we'll start in order of the indices. So we've got minus x cubed, minus an x squared, and minus an x and minus a 1. Now here we've got minus 4x, so minus 4x and minus x, that will give us minus 5x. So write that as minus 5x, and then minus 1 plus 6, that will give us plus 5. So that would take care of all those terms there. Okay, so now let's repeat again our denominator. Okay, right, let's do something with this side. So now what I'm going to do is I'm just going to rewrite these with a bit more space. Now you'll see why that is in a moment. So c x plus 1 plus d x plus 1 all squared. So now what I'm going to do is I'm going to multiply both sides by this term here. So if I multiply this side by this term, this will cancel out and just leave that on its own with no fraction. So that will take care of that. If I multiply each of these terms, is what I'm going to need to do, by this, then some of these terms are going to cancel out our corresponding denominators. So if I multiply this by this term, the x squared plus 1s will both cancel out. So that will go with that one and that will cancel out. And now we'll have x plus 1 squared to be multiplied with this term. So if I write that as x plus 1 squared to multiply everything there. Now same again here, I need to multiply this by x plus 1. So again, one of these x plus 1 squareds will cancel out and cancel out the denominator. Then I'll left with x squared plus 1. So if I multiply the c with x squared plus 1 and one of the other x plus 1s. So I'll put that on this side. Okay, now this time, this one, x plus 1 squared, that will cancel out all of that, and I'll be left with the x squared plus 1. So that will cancel out the x squared plus 1. Okay, so now what I need to do is to rewrite this as just this term here. So minus x cubed minus x squared minus 5x and plus 5. Now here I need to FOIL these all out. So x plus 1 squared, if I just rewrite that, that will give us x squared plus 2x plus 1. Then the x plus 1 with the x squared plus 1, that will give me x cubed plus x squared plus x plus 1. And this one here, that will just stay as it is with the d multiplied by that. So no need to FOIL that one out. Okay, so now let's rewrite this and then do the ax with this term and then the b with this term. So now I'm going to have a, then if I multiply x with all of this, I'll have x cubed plus 2x squared plus x. So x cubed plus 2x squared plus x. And now the b will be distributed with this one. So it's plus b. And then the term will just stay as it is. Okay, and now the c will be multiplied by all of that. So plus c times x cubed plus x squared plus x plus 1. And then this d times x squared plus 1, that will just stay as it is written there already. So dx squared plus 1. Okay, so now what I'm looking for now is to get my x cubes and x squareds and x's and my constants and write the coefficients that correspond to each one of those. And then our result then should give us corresponding coefficients to what's on the left hand side. So let's go through the algebra and then you'll be able to see what I'm actually trying to achieve. So now let's write the x cubed term first. So I've got x cubed, and now how many x cubes have I got? I've got an a, I've got a c, and that's all I have. So it's a plus c. So a plus c. Now let's look for my x squareds. So I'll add an x squared. And then what are my coefficients here? So I've got an a times 2, so that's 2a. I've got a b, I've got a c, and I've got a d. So I've got all 4 there. So I've got 2a plus b plus c plus d. Okay, now let's have a look what I've got for x. So for x I've got 1a, I've got 2b, a c. That's all I've got there. So a plus 2b plus c. And now for my constant, I've got a b, I've got a c, and I've got a d. So plus, and I'll just write here as b plus c plus d. So keep that all enclosed in a bracket, nice and easy to see. So now what I'll have is I've got x cubed here. Now for this to be the same, a plus c should be minus 1. Same here, x squared, I've got a minus 1 here, so that should equal minus 1. Here I've got minus 5x, so this should come to minus 5. And here I've got plus 5, so this should come to plus 5. So my corresponding equations that I need to solve for my coefficients is a plus c, that equals minus 1. I've got 2a plus b plus c plus d. So 2a plus b plus c plus d. That should equal minus 1 as well. Then my x term here should be minus 5. So I've got a plus 2b. So that's 2b plus c should equal minus 5. And then b plus c plus d should equal plus 5. Okay, so that's where we are so far. So now we need to use some kind of simultaneous equations or whatever we can do here to try and solve for each of these 4 variables. Now one method could be using the augmented matrix, but here I can see there's a little shortcut here where I could perhaps substitute for a d in here. So first of all, I'm going to take this bit off the board and then give myself a bit of space to try and work and solve for these 4 variables. Okay, so I've got an a plus c equals -1 here, and I've got an a and a c here, that equals -5. So I've got something similar going on there. Now, what I could also try is substitute for a d here in this a plus b plus c plus d. So if I've got this d here taken out of there, let's just bring this one up here, get d on its own. So d would equal 5 minus b minus c. Okay, so now this, if I substitute that into this equation, so I then have 2a plus b plus c. Now d, I know is this, so I can substitute this bit in for that. So plus 5 minus b minus c, and that would equal -1. Okay, so now I can see I've got a b and a c positive and a b and a c negative. These will cancel out. And now I'm left with 2a. So write that there. Get this 5 on the other side. I'll have -1 minus 5. So if I subtract 5 from both sides, 2a equals -6. So therefore a would equal -3. So that's one coefficient I can already see that I have. Okay, now if I know that a is -3, I can just plug that into this one. So let's write the equation up here. A plus c equals -1. A is -3. So I've got -3 plus c equals -1. So I can see straight away that my c must equal 2. So c equals 2. Okay, now if I know what a and c is, I can plug that into this one. So I've got a plus 2b plus c equals -5. A is -3. 2b we're going to find out. C is 2. And that's -5. Okay, 2 minus 3 is -1. So to get rid of -1 on this side, I need to add 1. So 2b will equal -4. So therefore b will equal -2. Okay, right. Now what's left to find? I've got a, I've got my b, and I've got my c. I just need to find d. Well, d is 5 minus b minus c. So let's plug that into there. So now d equals 5 minus 2 minus c, which is 2. So this will become 5 minus 2, which is +2, and that's -2. So these are just going to cancel out. So therefore my d is going to be 5. Okay, so now I've got all 4 of my coefficients that are required. So now this, in this form, in my partial fractions, I can now rewrite it. So let's just put my answer here. A is -3, B is -2. So I've got -3x minus 2 over x squared plus 1. C is 2, so I've got 2 over x plus 1. And my D is 5. So I've got 5 over x plus 1 squared. And that's it. That's partial fraction decomposition of this complicated looking fraction here. And that's going to take care of that. Okay.